Section 3.2, example 4. All right, step 1. Oh, let's go back to our steps. Here they are. Steps for graphing rational functions. Find the domain by factoring, right? Identify holes, then reduce, and then find an x and y-intercepts, find vertical asymptotes, find horizontal or slant asymptote, find additional points, find how the graph approaches the asymptote, and identify a location of holes, plot intercepts and holes, sketch everything, da-da-da. Kind of the same steps we've been doing in every section. We're just adding the slant asymptote and holes to the problem. Okay, here we go. Let's start by factoring. So we have f of x equals factors of 3x squared minus 2x plus 1, so that would be like 3x and x to get 3x squared, and then we need 1, like, since our middle number is a negative number, we probably need negatives both of these places, so that a negative times a negative is a positive, but I don't think this is going to work out, because a negative 1 times 1 and a negative 1 times 3 is negative 3x and negative 1x, which would add up to a negative 4x in the middle. I don't think this factors. So I'm just going to say nope to that, because it doesn't factor. We don't need to go further with that right now. Okay. So all we're going to do then is look at our x minus 1, set that equal to 0, and that means our domain is x cannot equal 1. Alright, and there's no holes because nothing factors and reduces. Da-da-da. Let's do x and y-intercepts. So for our x-intercept, we will set our numerator equal to 0 and solve. Now we already know it doesn't factor, so we'll have to do quadratic formulas. So x equals negative b plus or minus square root b squared minus 4ac all over 2a. Oh, that was a little off tune, sorry. B squared minus 4ac all over 2a. Okay, so that gives us 2 plus or minus 4 minus 12. Eek. That gives us 4 minus 12. That's a negative 8 in here and 6 down here. Now we can just stop. We could have just done this part. This means there are no x-intercepts because this would be imaginary, right? Because we're doing the square root of a negative. So no x-intercepts. Awesome. Y-intercept. So the y-intercept comes from simply plugging in x equals 0. So we just go 0 times 3, 0 squared, minus 2 times 0, plus 1, over 0 minus 1. Everything with zeros in it goes away. So I kind of did too far for that one right there. Everything with zeros goes away. So we have 1 over negative 1, which is negative 1. So that means we have a point at 0, negative 1, because we plugged in 0 for x and we got negative 1 for y. So 0, negative 1. There's our y-intercept. Okay, let's go to our asymptotes. So we already know that we have a vertical asymptote where the domain doesn't exist. So we have x equals 1 just from our first step, finding the domain. And that didn't reduce out, so it would be an asymptote. So I'm going to go ahead and throw that in there at x equals 1. And then let's see if we have a horizontal asymptote. So notice how the degree of the numerator, so this is kind of our important step here for this chapter, this section. So degree 2 over degree 1 means that since 2 is greater than 1, we have a slant or a diagonal. Not slant, slant. Oh, the whole thing went away. degree 1 means since 2 is greater than 1, we have a slant asymptote or a diagonal asymptote instead of a horizontal. Alright, let's look at that a little closer then by doing division. So we could do polynomial long division, or this one will actually work if we just do synthetic. So I'm going to change my x minus 1 to the positive 1, 0, and then we've got, the 0 of that polynomial function. And we've got our coefficients 3, negative 2, and 1. So bring down the 3. 3 times 1 is 3, negative 2 plus 3 is 1, 1 times 1 is 1. Obviously we didn't get 0, that doesn't really matter, we don't care, we just ignore this, ignore the remainder. So now our answer is y equals, and we're just going to take this thing right here, 3x plus 1. Okay, so we have a slant asymptote, 3x plus 1. That means it's going to go through a y-intercept of 1, and it's from there it's going to go up 3 over 1, up 3 over 1, up 3 over 1. So something about right there. So I don't know if you can see, but I've got my y-intercept at 1. I've got my slope of approximately 3 over 1, because that's a slope of 3, right? It's not exact, but we get the idea. So then we would plug in other points just to give us a general idea of where this graph is going to end up. And the result is something like this that's been graphed here with technology to confirm what we have so far. There's our vertical asymptote of 1, our slant asymptote up 1, and then up 3 over 1 for our slope. We've got that y-intercept there at negative 1. We've plugged in some other points, hopefully, and figured out where those pieces go, and then we can sketch those in approximately here and here, and voila, we have graphed our rational expression with the slant asymptote.